Hey gang, Mr. Spencer here. We've been talking a lot lately about how to set up scientific experiments. And one of the things that we're going to do today is dive into this idea of identifying variables. Now, what the big ideas that we're going to talk about are this whole concept of cause and effect in science, and then using that to understand what a variable is and be able to specify which of those variables are independent, which are dependent, and those things that we need to keep constant. So, as we've talked about what is science, one of the things that we've focused on is how in this class we're going to spend a lot of time seeing how when we change one thing, how that affects another. In other words, what we're doing is we're comparing, we're looking for patterns in that whole idea of cause and effect. Now, let's think back to this example that we've used quite a bit in class. Remember when we got out like the tennis ball and the racket ball and the golf ball and all of those things, and we wanted to know which type of ball would bounce the highest? Well, let's take a look at this and let's think about this. If our question is which type of ball bounces the highest, what are we comparing? Okay, what are the two things that we're trying to see the cause and effect of? Well, what we're doing really is we're comparing the type of the ball, which happens to be the cause, and the bounce height, which is the effect. These are all things that are called variables. Now, just in general, whenever we're talking about scientific experiments and variables, these are the things that we're changing and measuring. So in a lot of ways, what we could say is if variable number one changes, then what happens to variable number two? We want to see that cause and effect. We want to see how those two influence each other. So if I was looking at this, which type of ball bounces the highest, the variables that we're comparing here are the type of ball and what that type of ball does to the bounce height. Now, let's get a little more specific when we're talking about these variables. The first variable that we want to focus on is what's called the independent variable. Now, the independent variable is the variable that's being actively changed or measured. One of the ways that I like to think about it or remember it is that me the scientist, I am in charge of the independent variable. Okay. Now, in some classes, they might call the independent variable the manipulated variable, but we don't use that very much here. Just remember that the independent variable is what I am actively changing. Now, in this case, when we are comparing the ball type and the bounce height, which of these two things is the independent variable? Which am I actively changing? Am I actively changing the ball type or am I changing the bounce height? Well, I'm actively choosing which type of ball that I'm going to be dropping and seeing how high it bounces. So in this case, the ball type is our independent variable because I am in charge of changing it. I'm actively changing that. Now the dependent variable is the thing that changes as a result of the independent variable changing. Some people call that the responding variable. But this is our data. This is what we're collecting. So if we have once again this example of the ball type and bounce height and comparing those two, which is the dependent variable? Well, the dependent variable is going to be the bounce height. I'm in charge of the ball type. I'm in charge of that's the independent variable. But then as we actively change that independent variable, the ball type, we want to collect data on what happens with the bounce height. So that is our dependent variable. Or we could think of it as the bounce height depends on the type of ball that we drop. Now, one of the really important things that we have to remember is that in our scientific experiments that we're doing in class, we want to see how changing one variable affects the other variable. But in order to know if those two things are directly influencing each other, everything else needs to stay constant. It needs to stay the same. So there we have things that are called constants or controls. Those are the things that stay the same throughout the experiment. Okay, we aren't changing those at all. In fact, in our scientific experiments, we want to make absolutely sure that only one variable is actively changing at the time. Everything else stays the same. So if we were looking at our ball type and bounce height question, and we want to see how the ball type affects the bounce height, what would we need to make sure stays constant so that we know if the bounce height changes, it's because we changed the type of ball? Well, here are a few examples, and there's lots more, but we would want to make sure that the drop height stays constant, or that, for example, if I take the tennis ball and drop it from 1 meter, I also want to make sure that the golf ball gets dropped from that exact same height. I want to make sure that those are being dropped onto the same surface. I want to make sure that all of those are being dropped and not thrown down. You could come up with a lot more examples of that. But the most important thing is that when we're comparing the independent and dependent variables, we want to make sure that everything else stays the same. So let's do an example together. All right. So this is a little bit different than the ball bouncing and things like that. Let's say you're having trouble reading, and you go to the is it the optometrist? Is that the eye doctor? Okay. Well, this thought comes into your mind as you're sitting there, and you think, how does the size of a letter on a chart during an eye exam affect the number of letters a patient can recognize? Okay, so we've got a lot going on there. But what we want to do is figure out what's the independent variable, the dependent variable, and 3 things that should stay constant. All right. So first of all, let's figure out, what are we comparing? Well, if our question is how does the size of a letter on a chart affect the number of letters a patient can recognize, we're comparing this letter size and the letters recognized. Now, if I look at this, okay, which is actively being changed? Are we actively changing the size of the letter, or how many letters can be recognized? Well, we're going to be actively changing the size of the letter. That makes it the independent variable. Remember, I'm in charge of the independent variable. But the other thing that we're comparing, the letters recognized, that's the dependent variable. So we could say that the letters recognized depends on the letter size. But if I was doing this, like what kind of things would I need to keep constant? Well, I'd want to make sure that I have the same patient each time. Okay, changing patients would mess that up. We'd want to make sure that they stay at a constant distance away. They're not going further forward or farther back. Lighting, things like that. Okay, I know that was fast, but let me just go over this really fast, what we hope you've learned from this day. We've talked about the idea of cause and effect in science. We've talked about understanding what variables are, and then more specifically what independent and dependent variables are. And last of all, trying to figure out what things need to stay constant in order to be able to tell what that relationship is between the independent variable and the dependent variable. But before we go, I need you guys to try something out. And this is going to be something that you need to do on your own. But here's what I'd like to know. All right, here's the scenario. I am a horrible golfer. And let's say that Mr. Conrad and I are having a little wager on who can be the best golfer or who can win. And in an attempt to try to, I don't know, get a leg up, I go to the store and I'm looking at all the different golf balls, and I notice there's a lot of different brands, okay? And I noticed that some brands cost more than others. So I wonder, do more expensive golf balls travel farther than the cheaper ones? All right. So if that was the case, what would the independent variable, the dependent variable, what would those be, and what would need to stay constant? Give me 3 things. And what we'll do is we'll talk about that together when you're all done. Let me know if you have any questions.